to take this fixed nitrogen and add it to hydrogen. What is this?
That is fixed nitrogen in the form of fertilizer. And you are Fritz Haber, better known as one of history's most evil geniuses, coming up with a solution that both saved and killed millions. Born in 1868 in Breslau, Germany, he began experimenting chemistry in his bedroom before attending the University of Berlin. He pursued a PhD for chemistry and later became a professor of technical chemistry at the University of Karlsruhe. After becoming highly prominent in his field, he was sent to America in order to learn about foreign teaching methods. But chemist William Crookes predicted that the next 20 to 30 years would be marked by famine. Luckily, Fritz Haber found a way to artificially manufacture nitrogen fertilizers. In fact, while in the process of synthesizing ammonia in order to create chemical warfare used by Germany in World War I, he had accidentally created fertilizer. This isn't as coincidental as you may think, being that the fixing of nitrogen not only induces plant growth, but it can also be used to create bombs. The next year, the process was taken over by Carl Bosch for industrial development and created what is now known as the Haber-Bosch process. To top it all off, in 1918, he was awarded the Nobel Prize. So, how does this chemical process work?
A fertilizer is any material of natural or synthetic origin that gets added to plant tissues or soil to provide the plant with nutrients to enhance their growth. They typically provide the plant with three main macronutrients. This includes nitrogen, which helps with leaf growth, phosphorus, which helps with the development of flowers, roots, seeds, and fruit, and potassium, which enhances stem growth and circulation of water in plants. Fertilizers also give plants other secondary macro and micronutrients, such as calcium, magnesium, sulfur, copper, and zinc, to name a few. Nitrogen fertilizers are made from ammonia, or NH3, using what's called the Haber-Bosch process. This is an energy-intensive process in which natural gas, also known as methane, supplies the hydrogen while nitrogen is derived from the air. The reaction is reversible, and the production of ammonia is exothermic. In order to produce ammonia from nitrogen and hydrogen, the bonds in the diatomic nitrogen molecule must be broken. This is done by putting nitrogen under pressure over 150 bar and temperature over 400 degrees centigrade. Nitrogen then absorbs on an iron-based catalyst to finally split up the atoms. Only then can hydrogen bond with nitrogen atoms to produce ammonia. Because this reaction gives off heat, the ammonia reactor is cooled with a supply of cool gas. In a flow system of the synthesis gas, the equilibrium reaction can be prevented. Therefore, ammonia can decompose back into nitrogen and hydrogen. The liquid ammonia gets stored in a tank, while the remaining synthesis gases are returned through the reactor to form more ammonia.
What are the 5 chief uses of ammonia other than fertilizer? Number 1. The rubber industry. Ammonia is used in the rubber industry for the stabilization of natural and synthetic latex to prevent the premature coagulation of raw latex during the transportation from the plantation to the factory. Number 2. Color fabric dyeing. Ammonia is also used in the dyeing and scouring of wool, silk, and cotton. Number 3. Synthetic fibers. In synthetic or artificial fibers, ammonia is used in the manufacturing of nitric acid. Synthetic textile fibers such as nylon, polyester, and rayon. Number 4. Refrigerator fluid. 1 gram of ammonia can absorb 327 calories of heat, which makes it useful as a coolant in refrigeration and air conditioning equipment. It can often be found in the food, beverage, petrochemical, and cold storage industries. Number 5. The solvate process. Ammonia also finds application in the ammonia soda process, also known as the solvate process, which is a widely used method for producing soda ash.